Welcome back to Imperial International College and Pure Mathematics 2. Today we are going to be looking at the solution of polynomial equations. And one of my students has asked me the question, how do we solve the following problem that is on your screen? So we're going to tackle it today. F of x is equal to x cubed minus 19x plus 30. And we are asked to calculate f of 0 and f of 3, and hence write down a factor of f of x. Hence, by the way, means use whatever you've learnt in the previous question to help you to answer the question that follows. So let's start with this. Do you remember the factor theorem? If you don't, the first thing that you have to do is go to your textbook and go and memorize that factor theorem. But I'm going to take you through it again today. So here it is. It's not a long thing to remember. It's only a few lines at the top of your screen. And I hope that by the end of this video, you'll understand what this theorem means. I really never liked learning theorems off by heart when I was at school. It just seemed like an awful lot of words to try and memorize. But if you understand what the words are trying to tell you, it makes it a lot easier. So in the process of solving the different problems in this video, I'm hoping that this will come to life a little bit for you. So here's the theorem. If x minus a is a factor of the polynomial f of x, then f of a is equal to 0, and x is equal to a is a root of the equation f of x is equal to 0. Now, the first thing I want to talk about here, it sounds like an awful lot of words and probably none of it makes sense to you at the moment, but don't worry about that. I'm going to break it down into little pieces first. So the first little piece I want to look at is the word factor. Do you remember that factors fit? If I say to you, find me all the factors of 12. You will say, well, 1 will fit into 12, 2 will fit into 12, 3 will fit, 4 will fit, 6 will fit, and 12 will fit. So if I ask you, well, why won't 5 fit? You'll say to me, well, it will fit into 12, but the problem is it will leave a remainder. Now, a factor is a number that fits into another number, or a quantity that fits into another quantity without leaving any remainders. So that's the whole idea. So we're saying x minus a is going to be a little bit like 1, 2, 3, 4, 5, 4, 6, 12. It's going to fit into a polynomial. That would be the equivalent of like a 12 over here. This x minus a is going to fit into the polynomial, and guess what? It's not going to leave any remainders. Then it goes on to the next part, and this is my favorite part. Then f of a equals 0. Basically what they're saying is the really quick way to find out if something is a factor of some long polynomial over here is to test a number. So let's say I decided to make x 2. You would simply plug in the 2 everywhere that you saw x in your polynomial, and when you added it all up, hopefully it would add up to 0, which basically means you don't have any remainders. So if you are looking at a as being the factor, then we're saying x is equal to a. In other words, when x is a, that would be a root of the equation f of x is equal to 0. Here's another word that we're going to need to look at. What is a root? I'll tackle that as we go along through the video, and I'll keep coming back to this to hopefully start to make it make more sense to you. So I'm just going to go back to the original question. What are we supposed to do today? Well, we're asked to calculate f of 0 and f of 3 of the given polynomial. So let's go and do that. Here's our given polynomial, x cubed minus 19x plus 30, and we need to find f of 0. That means we're going to take 0 and we're going to place it wherever you see x. So the first place we see x is at the beginning of this whole equation, f of 0 equals. Now we start plugging in 0 every time you see an x. So it's going to be 0 cubed minus 19 times 0 plus 30, which is going to give us 0 minus 0 plus 30. And the 30 is what's left over. So f of 0 is equal to 30. Whoopsie. Can you see that f of whatever the number is here, a, should give us 0? And we've ended up with 30. Well, what that's telling us is that there's a remainder. In fact, the remainder is 30. There shouldn't be a remainder if 0 was a factor of the polynomial. So we know that 0 is not a factor of the polynomial. So the answer to this is an emphatic no, it's not, because we have a remainder. Going to the second part of the question, they asked us, well, what happens if x is 3? We were asked to calculate f of 3. Well, that means we start plugging in 3 everywhere you see x. In the first place you see x is f of x. We're going to say f of 3. In other words, this equation is going to take 3 as the value for x all the way through. So it's going to become 3 cubed minus 19 times 3 plus 30. 3 3s and 9 3s are 27. Minus 19 times 3 is minus 57 plus 30. That then gives us, if you add the 27 and the 30 together, it'll give us 57. Minus 57, hallelujah, we have got a 0. So f of 3 is equal to 0. Is it a factor? Yes. Now how do you write it as a factor? Do you write 3 is a factor? No. What we're saying, if you go back to the theorem, we then are saying that x minus a is a factor if when you plug in a into your equation, everything ends up equaling 0. So how do we write the factor? We say that the factor is, we say that the factor is a, x minus a. And so the way that you write the answer down is to simply say x minus a is a factor. So what was our factor over here? 3 was the factor. So we write x minus 3 is a factor. There's another point I want to really bring your attention to. Please notice that this has to be a minus. You don't get a choice in that. X minus 3 is a factor. Now what if minus 3 was a factor? Then we'd have to say x minus, because remember you don't get a choice, and then what was the number? Minus 3 is a factor. Now this obviously wasn't the answer to the previous sum. I'm just trying to show you what would happen if this number was not 3. What if it was f of minus 3? You had to plug in minus 3 everywhere you saw x. If that ended up equaling 0 in some fictitious sum or problem that you're trying to resolve, the way that you would write it is x minus minus 3 is a factor. And that would give us x plus 3 is a factor, because a minus times a minus is a plus. So we basically always going to use a minus sign in this theorem. The theorem is if x minus a is a factor. It's not giving you a choice. I hope that that makes sense. Now we're going to move on to the next part of the question. It asks you, find p and q such that f of x is equal to x minus 2 into x squared plus px plus q. Looks like gobbledygook, doesn't it? How are we going to find p and q? Well, we can't if we just had this information, but this is the second part of a question that we've been working on so far. And what we've worked out so far is that f of 0 gave us a remainder of 30. If you remember, we worked that out. F of 0 was not a factor. It gave us a remainder of 30. So if we write f of 0 here, and we plug in 0 everywhere you see x, and you add that all up, it should equal 30 because f of 0 is 30. So let's do that. We're going to put in a 0 where the x is, minus 2, and then we're going to put another 0 over here. This p is multiplied by an x, so it's going to be 0 times p, and then the q is not multiplied by any x, so it's left over as it is. What have we got left in this bracket? 0 minus 2 is minus 2. Our x's disappear, our zeros disappear. So the only term that we're left with, because remember 0 times p is going to be 0, the only term we're left with is q. So we get minus 2 times q. The elegant way to present it is to write it as minus 2q. And what do we know it's equal to? 30. So if minus 2q is 30, then q has got to be equal to minus 15. That's simply changing the subject of the formula. If that doesn't make sense to you, please send me an email and ask me to do a video for you on changing the subject of the formula, but hopefully that does make sense. So far we've got q, but remember we were asked to find p and q, so we're halfway there. We've got q. Now that we've got q, we can substitute q into the equation again, so we can immediately put, instead of having q, we can write this as minus 15. But where do we go from here? The only other piece of information we had from the previous section was that f of 3 gave us 0. We know that f of 3 is a factor. So our equation now says x minus 2 into x squared plus px minus 15. And if we use that and we say, well, I tell you what, we're going to say f of 3 is equal to 0, then we're simply going to substitute for x minus 2, we're going to write 3 minus 2. So let me write that over here. 3 minus 2, because we're working out f of 3. So we're going to say 3 minus 2, and then in the next part of the equation we have x squared, that's going to be 3 squared, which is 9, plus px, well we know that x is 3, so that's going to give us plus 3x, and q, fortunately we know is minus 15, and the other thing that we know is that when f of 3 is placed into this equation, we know it's a factor, so it all equals 0. So that's where we are over here. 3 minus 2 into 3 squared plus 3p minus 15. So let's carry on from there. 3 minus 2 gives us 1, and 3 squared gives us 9. I've taken this minus 15 over to the left. I like having these two terms together, plus 3p. Now 9 minus 15 gives us minus 6. And I've written 3p at the front because it's just more elegant maths to have your terms that excuse me, the terms that have variables in it at the beginning of an equation. So we have 3p minus 6 is equal to 0, and we end up with 3p is equal to 6, and p would equal 2. So we have now solved the second part of the problem. The third part of the problem asks us to solve this entire equation when the equation is equal to 0. The way that we do that is we use what we know. Now remember that this equation in the previous, in part B, was written as x minus 2 into x squared plus px plus q is equal to 0. Now we know that p is equal to 2 and q is equal to minus 15. We know that from the previous sum from b. Remember, p was 2 and q was minus 15. So if we have this whole equation over here, we can now substitute the value for p and q. It's starting to look a little bit better. X minus 2 is equal to x squared plus 2x, because we're putting p is equal to 2 over here, minus 15 is equal to 0. Why have I done that? Well, remember that this equation, which is what we're trying to solve, can be written as this equation. How do we know? Because they told us so in part B of the question. So now we have x minus 2, and then we simply have a quadratic equation here, which is pretty straightforward to solve. This resolves into x plus 5 multiplied by x minus 3 is equal to 0. That means either this bracket, or this bracket, or this bracket is responsible for making the entire thing equal to 0. So either x minus 2 is equal to 0, in which case x would equal 2, or x plus 5 would be equal to 0, in which case x would be minus 5, or x minus 3 is equal to 0, in which case x would equal 3. I hope that that makes sense to you. So now we have got 3 roots of the equation: 2, minus 5, and 3. A root is basically the number that you would plug into the given bracket to make the bracket equal 0. So if I plugged in 2 over here, 2 minus 2 would give me 0. Minus 5 over here, if I plugged in minus 5 over here, minus 5 plus 5 would give me 0. And if I plugged in 3 over here, 3 minus 3 would give me 0. So at any given point, if any one of these numbers is 2 or minus 5 or 3, the entire thing is going to equal 0. What is the entire thing? Do you remember that the entire thing was a function, f of x? And do you remember from functions that f of x would equal y? So we're saying that when x is equal to the following values, y would be equal to 0. If you're given a graph, when is y equal to 0? If you had a point over here, can you see that this has got an x coordinate and a y coordinate, and the y coordinate is certainly not 0. The only time when something would have a y value would be of 0 would be when the set of coordinates is sitting exactly on the x-axis. Each of these would have a value for x, and in every case y would be 0. So basically what you've worked out when you found a root, you have found out everywhere that your function is cutting the x-axis. And that's what a root is. You're finding out where the function is cutting through the x-axis. So now we come to the next part D of this problem. Without further calculation, draw a sketch of y is equal to f of x. Are we allowed to substitute all sorts of values and create a table in order to draw the graph? No, because it says without further calculation, just from what you know so far, draw the graph. Well, what do we know so far? We know it's a cubic function. How do we know it's a cubic function? Because the function begins with the value x cubed. The first value has the exponent 3. So we know it's a cubic function. Now, bear with me. I'm just going on a slight little meander into a recap of functions here. Do you remember that a linear function was written as y is equal to, in fact, I'm going to change this, ax plus b. Y is equal to ax plus b. And that was a straight line function. When you had a quadratic function or a quadratic equation, it would be y is equal to ax squared plus bx plus c. And this would be a parabola. And finally, if you have a cubic function, the cubic function would be y is equal to ax cubed plus bx squared plus cx plus d. And a cubic function looks like a letter S cutting through the x-axis like that. So I want to ask you if you can see a pattern here. When you have a linear function, y is equal to ax, I'm going to call this ax to the power of 1, ax plus b, and that's a linear function. When you have a quadratic function, it becomes ax squared plus b, and the b gets an x, plus c. And when it's a cubic function, it becomes y is equal to ax cubed. The bx becomes bx squared. The c gains an x, and we add d. Can you see how this is increasing as the value, the order of the equation is increasing from 1 to 2 to 3 as we go down the line? Just a reminder, a linear equation looks like this. Quadratic equation looks like a parabola, well, it is a parabola, and a cubic function looks a little bit like a letter S on its side, back to front, cutting through the x-axis. So now let's just go back to our equation. Our question, we were asked, draw the sketch y is equal to f of x. So here we go. What do we know? Well, we worked out the roots. Do you remember one of the questions? We worked out that x was 2, x was equal to minus 5, and x was equal to 3. Do you remember what a root is? It's where the graph is cutting through the x-axis. If it's cutting through the x-axis, then the y value every time has got to be 0. Because that's the only time you could be near the x-axis if his y is nothing at all. So if x is 2, we know that 2, 0 is a coordinate on the graph, minus 5, 0 is a coordinate, and 3, 0 is a coordinate. Also, do you remember that when we plugged in f of 0, we saw it was not a factor, but we did see that when x was 0, y would be 30. So when x is 0, where's y? 30. That's telling us where the graph crosses or cuts the y-axis. So we now know where it's cutting the x-axis and where it's cutting the y-axis. So let's draw it. We know that it's cutting the x-axis at 2, 3, and minus 5. And we know that it's cutting the y-axis at 30. How exact is my graph? Probably not exact at all. But all I need to know is that it's an S shape. I need to know that it's going to cut the graph on its way up on the furthest left-hand side root. It's going to cross the y-axis at 30. It's going to cross the x-axis at 2, and then it's going to cross the x-axis again at 3. And we know that every cubic function is an S shape. So my S shape might not be this at all. This graph could potentially, for example, look like much taller, much steeper like that. It doesn't really matter what it would look like, as long as you've got an S shape and you're showing the examiner that you understand that a root is where the graph cuts the x-axis, and that you've been able to find a y-intercept to work out where it crosses the y. And when you do that, all you're doing is creating a rough sketch. In the exam, there's a vast difference between sketch the graph and plot the graph. Sketch the graph means rough drawing, like I've created here. Plot the graph means create a table and then put in all your values of x, like you did in IGCSE. Put in all your values of x across the top and work out what y would be if x took any particular value. And from that table, you'd plot a whole lot of set of coordinates and plot the graph. This has got to be accurate. The question didn't ask us to be accurate, simply asked us for a sketch. So I hope that helps. Just a reminder, we were asked, without further calculation, can you draw a sketch of y is equal to f of x? Now I'm going to go right back to the factor theorem. If x minus a is a factor of a polynomial f of x, Then, when x is a, the polynomial f of a will be 0, x will be equal to a, and that will be a root of the equation f of x is equal to 0. In other words, a root will mean that whatever a is, a and 0 will be one of the coordinates on the graph, because y, in other words f of x is y will be equal to 0 when x is equal to a. I hope that this helps you understand the factor theorem a little bit better. Please go and learn that factor theorem as well as you know your own phone number. It's really important for your AS level exams. You're expected to know it. I hope that this has been of some help to you. It's quite a long video, but I hope that it helps to answer the question. Thank you for watching. Send me an email if you need any help, and I'll see you next time.